Have you ever wondered what lies beyond the boundaries of our Earth's atmosphere, our solar system, or even our universe? Friends, today we will take you on a journey beyond the boundaries of the universe. So stay with us. A theory suggests that our universe has a boundary, a literal edge. But before we explore that boundary, let me tell you just how vast our universe is. For someone who doesn't understand scientific equations or physics, it's almost impossible to grasp its enormity. Within this immense universe, there are colossal structures like superclusters, ordinary clusters, giant galaxies, and smaller entities like solar systems. Our solar system is just one of these, and in comparison, our Earth is merely a tiny dot. Today, we are going to transcend the boundaries of all these cosmic objects, but for that, we need a massive spaceship that can travel faster than the speed of light. So, let's start the engines of our spacecraft and begin our journey from Earth. First, we reach a point 100 kilometers above sea level. This is the Kármán line, the boundary between Earth's atmosphere and outer space. No commercial flight can reach this altitude. Passenger planes only fly up to about 10 to 11 kilometers. Crossing the Kármán line takes us into outer space. From here, we proceed to the boundary of our solar system, passing Jupiter, Saturn, Uranus, and Neptune. Traveling at high speed, we reach 100 astronomical units from Earth. 1 astronomical units is about 150 million kilometers, the average distance between the Earth and the Sun. At 100 astronomical units, we reach the edge of the heliosphere, where solar winds slow down significantly. Next, we encounter the heliopause, where solar winds cease and interstellar space begins. Even beyond this, we may find NASA's Voyager 1 and Voyager 2, which crossed the heliosphere's boundary in 2004 and 2007, respectively. After crossing this boundary, we reach interstellar space and journey 200,000 astronomical units away at an imagined speed faster than light. Although no object can actually exceed the speed of light, let's stretch our imagination to traverse the universe quickly. In this vast expanse, we encounter countless rocks and massive clouds of debris. This region is known as the Oort cloud, starting at about 5,000 astronomical units from the Sun and extending up to 100,000 astronomical units. It's a gigantic shell of icy objects that envelopes our solar system. So, as we continue this imaginative journey, we move beyond all known boundaries, exploring the immense and mysterious universe. Friends, this cloud is the extension from where many comets come to visit our solar system. When these comets are in the cloud, they are made up of ice. As they approach the inner solar system, the sun's heat causes their ice to melt, giving them the appearance of a shining star with a tail when seen from Earth. These are the comets we observe. Scientists believe that most comets that visit the inner solar system originate from this Oort cloud extension. This cloud is so vast that it will take the Voyager 1 spacecraft about 300 years to reach its inner boundary and approximately 30,000 years to exit the cloud completely. Even beyond 100,000 astronomical units, the density of the cloud doesn't drop suddenly but gradually. Despite the presence of many objects and rocks, their distances are so vast that our spacecraft can easily navigate through them. As we travel further, we encounter empty, desolate space and complete darkness. The faint light we see comes from distant expanses, indicating that even though we have left our solar system and the Oort cloud, we are still within our Milky Way galaxy. The Milky Way is immense, spanning about 106,000 light years. To put that in perspective, 1 light year is the distance light travels in a year, about 9.5 trillion kilometers. Traveling at conventional rocket speeds, it would take us about 1 billion years to cross the Milky Way. However, imagine we are in a spacecraft that moves thousands of times faster than the speed of light. In just a few hours, we would reach the edge of the Milky Way. Looking back, the Milky Way would appear as a large spot, and ahead, we would see small spots of light. These are other giant galaxies, some even larger than the Milky Way, appearing small due to their distance. Even in this vast emptiness, the universe isn't truly empty. Dark matter and dark energy permeate this space, binding galaxies and all matter in the universe. As we move further, we see another ring of small galaxies forming behind us, and eventually, we encounter a large group of galaxies. This is a cluster, our cluster, which includes the Milky Way. This large cluster is known as Laniakea supercluster, and our Earth is part of it. In this supercluster, there are more than 100,000 small and large galaxies. Together, these galaxies form the supercluster, and many such superclusters collectively form our universe. This is the observable universe, comprising all the small and large galaxies and superclusters. Scientists initially believed the universe was infinite. However, research has shown that the universe is divided into two parts: the observable universe, which we can study and in which matter exists, and the unobservable universe, beyond our observational limits. As science has developed, some scientists have discovered that our observable universe, which spans over 93 billion light-years, has a boundary. Beyond that boundary lies emptiness and darkness, an expanse with no light, no matter, and no illumination. If we journey beyond this boundary into the dark expanse and look back, we might see our entire universe as a mere speck, with our galaxy and supercluster invisible even as a point. We, humans, would be like a tiny drop in a vast ocean. If we could travel thousands of times faster than the speed of light and try to return to Earth, the concept of time being relative means we would have traveled so far into the future that millions of years would have passed. By the time we got back, our solar system, Earth, and even our galaxy would no longer exist. Our galaxy would have ended millions of years ago in the time loop. Hence, going back is futile. We can only move forward. Our galaxy, universe, and solar system would all be gone. But here we are, sitting in our superfast spacecraft, having reached the end of the universe, approximately 93 billion light-years away from our home. As we accelerate even further, we leave our observable universe behind, crossing its limits and entering the vast emptiness beyond. This expanse is known as the iridinous supervoid. This supervoid is not like the voids you may have read about or seen in videos on YouTube. It is a massive empty space within our universe, spanning about 330 million light-years, devoid of galaxies, planets, and matter. No one knows how such a vast emptiness was formed. However, the iridinous supervoid we are discussing here is even more extensive, possibly spreading over at least 1.8 billion light-years. Some scientists believe that this supervoid might indicate the presence of something beyond our universe, suggesting the existence of another universe. This idea gives rise to the multiverse theory, which posits that there are many universes like ours, each separated by a supervoid, a massive emptiness that divides all observable universes from each other. Imagine these universes existing as bubbles within a larger multiverse. While the theories discussed here are not yet proven, they are based on scientific principles. What do you think about the multiverse theory? Do you believe it could be true? Let us know in the comments, and stay tuned for more knowledge. Take care and have a wonderful day.